When the actual graph is 0, okay, we have a name for that. We call it an intercept. Right? When the first derivative is 0, what do you call that? First derivative is 0. That's a stationary point. It might be a turning point, but it might not be. Okay, so stationary point. Now, and if you think you know the answer to this, just hold on for a second so we can all think about it together. When the second derivative is 0, what would that mean? What would it signify? Now, I'm going to give you a name for it in a second, but I want to try and illustrate the idea for you first. Let's go back to that graph, okay? This time, I've put pluses and minuses on to indicate gradient, okay? This time, I'm going to put them on to indicate concavity, okay? So, for this part of x cubed plus x, I'm concave down, okay? And then over this side, I'm concave up. Now, how would you describe the concavity of this point? Well, I do go from negative to positive, and the thing between negative and positive is 0. How can we check that out? Well, you remember, we drew on the second derivative, right? This is y, and this is the second derivative. And sure enough, at the origin, the second derivative is 0. Okay? So what does that mean? It's not concave down, and it's not concave up. It's, well, if you had a lens, right? You'd say it's concave, or it's convex. What would you say if it looked like this?
It's a pane of glass.
It has no concavity, right? Actually, in terms of light, it's not going to do any lensing to it at all. It's not a lens. So therefore, at this position here, we would say, number 1, it has no concavity. Okay? It's not concave up, it's not concave down, but we can do a little more than that. Okay? Can you remember, why do we call it stationary? What does stationary have to do with anything? Yeah, so it's a geometric description, okay? It tells you about the shape. Now here, how would I describe this shape? Well, we call it a point of inflection. What does inflection mean? It's a weird kind of word, right? You can spell it with a CT if you like, but more commonly I see it with an X. I don't think it would matter which way you spelt it, but I always spell it with an X.
So what's actually?
I've never seen CT.
I've seen CT. If you read enough maths textbooks, you'll meet CT eventually. Okay, so can you see what's happening, right? Can you imagine it kind of like a bendy ruler, okay? And you're flexing it back and forth. And this is the place where it flexes from one direction to another. So it's kind of, that's where this inflection idea comes from, okay? So a point of inflection, or if you like, P-O-I, okay? So that abbreviation is sometimes used. Yeah, it's pretty terrible. How do you go about finding a point of inflection, okay? Well, the most obvious answer is, you do this, okay? You let the second derivative equal to 0, okay? And that's fine. Most of the time, that will work.